Well, actually, I find this somewhere. I will talk about connect. So I'll skip it until when I talk about Euro 4 and Euro 7, then you can see this one more time. So this just give you all the details information, especially if you are interested about the I mentioned about our region of interest alignment here. If you are interested about the detail how make this example. If you have an image like this, then you divide it into a 3x3 grid, for example. Then the value here, see, as you see here, they are not integer. They are not integer. 好，就是这个影像大小，你把它分割成3×3那个 grid， 你也知道，它对应的不会是整数，它不会是整数。Okay, they are not integer, for example. Okay, then how to handle this, or you might have a bounding box, okay, like this, right? When you upscale back, you identify the bounding box in some feature map. Then you have to look back to the original image. Actually, the bounding box is not integer, okay, or vice versa, okay. So how to estimate the value for this example here? That the value actually is 0.25 and something. How I won't say anything, but I just show you all the details here. If you're interested, you can look for how it works, okay, with the figures, okay. Just too tedious, but if your research is something to do with it, or for any reason you want to change it, you will say why ROI or 9 is better than ROI pool. Okay, I'll skip. But here's the details. Okay, how you do the calculation, how you convert the real number into integer, and how to make the estimation and so on. Okay, I won't say anything about it. It's just too tedious to talk about. Okay. 好，这里有很多细节，好，有兴趣自己看。我能够帮你找到的资料都在这里。好，我也没看过写这么详细。Okay. Okay, that's about the end about object detection. Okay. Regional, CNN based, and YOLO. Okay, and then we can talk about okay, the YOLO 4. Okay, YOLO 4. You can find it here. YOLO 4. Okay. Well, actually, the material here is more than YOLO 4, but we don't have too much time. But here's some other model called efficient net and efficient detection. Efficient detection is based on efficient net, but efficient detection is the baseline is efficient net, but efficient detection is used for segmentation. Okay, 它用来做分割。Okay, but I will focus on YOLO 4. Right, I even have a transformer, but personally, I still not convinced to use transformer for images, but I may include the transformer for the data pattern next semester, because transformer could be better for time series data. Okay, but I still not convinced to use transformer for image. Anyway, efficient net. Efficient net, it will guide you or tell you what will be the best model or architecture based on right here, the depth, okay? How many layers, how many convolution layers you need. And then also we will talk about the width scaling. For each layer, how many filters you need. 这个宽指的是每一个 convolution layer 你要用多少个 filter 比较好。这个呢，你要走多深 ？Just like residual net, it has up to 150 something. But for VGG, you know, it use 16 or 19 layer. Okay, but the number of filters could be different. So now the question is, should we go very deep, or should we go very wide, but with only a few convolution layers? Now the other question is right here. What should be the input size, which means the resolution, given the image, even the original image size, just like your assignment number 5. The original image is what? 7K by 7K. You have asked, do I need to use 7K by 7K as the input just for a given task? That's something you need to ask. Okay, you know what I'm saying? Okay, if you try to identify the gap of the wafer die, 70 by 70 definitely is not enough, right? 你不可能用70乘70，然后你找出那个 gap， 找不到。But the question is, do I need 7K by 7K, or I simply reduce it to 1K by 1K? So here's these 3 questions to build up your architecture that will be answered by using efficient lab. I didn't efficient lab can answer your question, but you discussed a lot about these 3 parameters to build up a best CLM-based architecture. Okay, not just the depth or the number of convolution layers and the number of filters in each convolution layer, but also you need to ask what should be the resolution, so that will be fast and also very effective. 又有效又快 ，OK， 这3个 ，anyway, then you will come up with this is not my main topic today, but anyway, you use 3 parameters here. Okay, you will determine the depth, the number of layers, the width, the number of filters, and the resolution, the input image size. Okay, you will discuss this. Okay, alpha, beta, gamma, and what will be the best combination. Okay, and then come up with the efficient net, and then use efficient net for segmentation. Okay, that's something you can watch out. Okay, I will skip that. Okay. This is the efficient net for segmentation, okay, based on efficient net. But it talk about this. Here's as I mentioned, just pan net. Well, actually, this model is not right. This model. This is button up. Right, button up. Okay, input goes through. Okay, it downsizing, and then this is what top down. So what is this model? FP.
Pyramid.
Right, feature pyramid network. Well, actually, it should not present something here. Okay, just these two columns. Okay, this model is not right. Okay, FPN just bottom up, top down, pyramid. Okay, that's it, and then you make an estimation. Here is PN. Okay, the same here, bottom up, top down, and then bottom up again. See that? Okay, that's the FPM. Okay. There's a lot of research. They use, for me, it looks weird, but anyway, it works. You make all kinds of connection. This connection, that connection, and it find out it works. It's better than any model, so you can get published. I'm not quite sure if you try out the UNet Plus, and UNet U2, they all use the same idea or strategy. They do the connection, not just the encoder layer connect to the corresponding decoder layer. They use a lot of different. Take a look here. It's just layer to layer connection. When I say connection, could be element-wise addition or concatenation. Here's something. Say this could be more. See that? Could be more effective. It's just a meta connection here, and this will be similar to the same as it's called. It uses a lot of different names. And this is another, it connects all the layers. See that? And as long as it's better than the original one, but I'm not quite sure which one. Anyway, this could be the one used. Okay. It's very similar to the PANet. Okay, but you can think of this as just like the residual net. You connect, right? You cross over, okay, to the middle column. Definitely, I'm not supposed to. You're going to use this. I mean, the training will be very tedious. Okay. Anyway, there's a lot of. Okay, just button up, top down, and then button up again. Okay, but the connection is layer to layer. Okay, with corresponding. Okay, so that's PANet. And efficient detection, they use this model. They use this model, okay? And they found out it's quite efficient, okay? That's something if you want to use it for segmentation, that could be something you can try out, okay? Right here, okay? But anyway, see that compare with the math ASEAN, okay? Different parameter or different architecture. Efficient detection is D7. Then the number of parameter, okay? It just show you the relationship, okay? The number of parameter you need to train and the average performance, okay? But, okay, so that's what I want to say is right. here, Euro 3. Okay, this is compared with computational efficiency. Okay, the larger the better. Okay, the larger the better. And this is the performance for instance segmentation. Okay, so this Euro 3 says efficient detection, even with the simplest efficient detection. I mean, performance is better than Euro 3 and mask RCN here. Okay, so here's something you can watch out. Okay, you can watch out. So efficient detection or efficient net is another simple model you can download and to use it for your own application. Okay. Here, the Euro 4. Okay, this is something I want to share with you. This is the performance of Euro 3. Okay, and here's the Euro 4. So in terms of the performance, okay, average precision and this frames per second. See that? I mean, Euro 4 is quite fast. It's quite fast. Okay? So it can up to what? More than 100. See that? Okay? If you sacrifice some of the performance. But anyway, even for this one, everything is better than Euro 3. Okay? And the computation efficiency can be more than 100 frames per second. And the performance is relatively still pretty good. Okay, pretty good. Okay, but efficient net is right here. Okay, the performance is still pretty good, but the efficiency is still not as efficient as the Euro 4 now. Okay, but the performance is pretty good. Okay, still pretty good. So efficient detection for segmentation is still one of the model that you can apply. Okay. Euro 4 is almost impossible to talk about every single details because you mentioned a lot about you compare a lot of different backbone, okay, as the baseline model. You talk about the net. Well, actually, for object detection, you will talk about the backbone. It's just the name, everything is nothing but just the convolution layer. Okay. The backbone usually is residual net. Then net, you can think of as a feature pyramid network. And finally, called head. It could be just a few convolution layer for classification. For bounding box estimation. That's it. Okay? But you use different names for that. Okay? The backbone, residual net, FPM, you use the pyramid, okay, to estimate the region of different objects in different sizes. And finally, it connects to a field convolution layer, okay, to estimate the class, the bounding box, or even for mask. Okay, that we use the name here. So in Euro 4, you try out different models. So here's the net. It talks about a lot of different. See that FPN, okay, PN right here. See that? Okay, you try out different. Okay, and for the head, Again, we use RPM, this and that, and then even for activation, it varies different residual lag, decay value, and blah blah blah, and finally they come up with mesh. Okay, it claims it performs better than any other, but there's no way you can try out all the combination and pick out the best one. But anyway, that's what they did. Okay, even for the bounding box, besides IOU, okay, you try out different combination. I'll show you. Okay, with this. Okay, and then it try different strategy for data augmentation. Not just rotate the translation or scale. No, they try out a lot of different method you never think of. But anyway, the only purpose is trying to make the model robust, okay, to the environment changes and another and different skip connection. You try out to residual connection, weight the residual connection, addition, concatenation, blah blah blah, all the combination. Well, actually, if you want, you can look for the original. I mean, it's too small, I cannot see it. You try out all the different combinations. This and that, blah blah blah, and then you come up. See that for data augmentation, you will try out, cut out, and this and that, and what do you mean by drop out? You can understand here and drop out, but what about the image drop out for augmentation? Okay, I will show you that. Okay, anyway, you try a lot of different, even labeling, use so-called soft labeling. I mean, if a cat is 1, dog is 2, no. You may say cat could be 0.9 something. Okay, it doesn't use a crisp value. Instead of we use the so-called soft labeling and box. It measures, I mentioned, we use IOU loss function and this D could mean distance IOU. I will show you why. Okay, later on. And try out a lot of attention, future fission, blah, and activation, see that you try out value, this switch. I mean, finally they use mesh, okay? They use mesh. Okay, so many combination, and there's no way I can talk about all the details. But anyway, the claim is far better than Euro 3 in terms of the computation time and the detection performance. Okay, let me just show you some of the key points. Okay, for Euro 4. Okay, but there's no way I can talk about all the details. Okay. Here's the architecture for Euro 4. You can take a look. Okay, it's something like this. This is the backbone. This is the neck. Okay, and this is the head. Okay, and it shows you what are the each individual block represented. Okay, you can take a look at the details, but anyway, it says what will be the backbone you use. Okay, it's still based on residual net. Okay, but it's called dark net. Okay, the neck is I'll show you later. Yeah, this is much easier to understand, okay? Anyway, the backbone is kind of a residual net, okay? and then you apply what? The feature pyramid, okay? It's still quite similar to feature pyramid, okay? Feature pyramid. And the output is P2, P3, you use the P3, P4, and P5 to handle the scale variation, and then connector hat, as I mentioned, hat is just another convolution layers, okay? Then you can make the prediction about the class and the bounding boxes, okay? Parameter, that's it, okay? So the basic idea, just very much just like what you have seen, okay? But it changed a lot of fine details, okay? So that's the basic idea, and this one gives you more details for the backbone, for the neck, and for the head, okay? First, if you want to take, you can look how you smooth the level instead of use 0 or 1 to represent different class level. Okay, too tedious. I won't say anything about it. This drop block is for data augmentation. It does something like this. Actually, you can think of this just, remember when I talk about autoencoder, I talk about mask autoencoder, right? Mask, it do the similar thing here. First, this is the input. Now, first, you mark, you just mark the region, okay? Or you find the region that you are going to drop out. So for this case, maybe this is the object. So you put this, okay, the blue color region as the one, okay, you might to drop out. Now here's what it did. First, you randomly, okay, from the region that possibly contain, you need to do it manually, okay? The region. Then you randomly pick up the pixel. And then you determine the size of the mask, okay? For example, once you select this point here, you take it as center, and then suppose the mask is of size 5 by 5, okay? 5 by 5. Then you find all the neighbor and set it to 0. That's it, okay? Then you can have a more robust training of your model, okay? Actually, the idea just very much just like the mask, right? You remember last time, let me see. Mask, okay? Auto encoder, the same here, okay? So first, you randomly pick up the point, then determine the window size of the mask size and all the pixel point in the mask. Then you just repeat. Just like what the original dropout, right? You make the connection. You need to make the connection, right? For every 2 points, sometimes you may drop this point, right? This node. This is for your model, but this is for your input image and also the feature map. Which means you can apply the dropout, right? Before the output layer, you can do it for the convolution layer. This is the same here. You can apply this to your input. You can apply this to your feature map, okay? And it gives you a better performance, okay? So that's something called drop block, okay? So it applies to image or feature map, okay? So you need the augmentation. You can think of this as another kind of augmentation, okay? And it gives you a better performance. And as I mentioned, finally, they use mesh, Okay, Mitch. Okay, here's the equation, and here. Okay, if you go for the naked red rule, it will what? It will linear increase, right? With the negative value. I'm not quite sure why they didn't try out chair rule. I mentioned this, right? Gaussian error. It have the shape pretty much like
mesh.
Like mesh, right? They pretty much, but apparently they didn't compare with it. I don't know why, but I checked with Bob and ChatGPT. Mesh is developed after Gaussian error, so that's why I don't understand they don't try out this one. Okay, if mesh is developed before Gaussian error, that is you can understand it, right? But they, I don't know. Anyway, mesh apparently, see that? I'm quite surprised. Okay, the X is the number of layer, convolution layer. So when layer goes deeper, and see that the testing accuracy, it drops significantly when it getting deeper. Now, that's the performance of red rule. See that? The performance is getting worse. But it seems okay for the switch, but eventually it dropped. And apparently with mesh, okay, it depends on the handwritten digit, okay? It keeps the performance pretty high, even the number of layers increasing from 15 to 23, 24, something, okay? So it means the mesh activation function is more stable, but I still don't know if the performance is better than the Gaussian error or better than Gaussian error, I don't know. But anyway, it showed a significant difference, okay? Significant difference with ReLU or switch, okay? Here comes CSP, okay? That's something they propose, okay, in YOLO 4. This is the traditional way, okay? The input, it goes to the dense block, and then go for the next layer or the transaction. Usually transaction means a one-by-one convolution, and then you connect to the next block. Now, here's why it getting faster with CSP. Now, here's the input, okay, from the previous layer. It's separated into two parts. The input separated into two parts. One, skip the computation, the convolution, or the dense block, which means you need to go for a series of convolutions. But the other part, directed connect to the transaction, which means then you go for the concatenation, which means you can reduce the computation by half. You separate the input into two parts. Into one half go for this root, the other one go for this root. Usually it is separated by the channel. Okay, it's separated by the channel. If you have a channel of 100, you might assume that the very first 50 channel, they go directly to right here. and the remaining or the second half of the channel, you do the convolution so that you can reduce the time without sacrificing the performance. OK， 知道意思吗？它是把它拆成2部分，就这样做啊。一部分呢，直接呢就不要做，接到下面去。这边呢做一些 convolution， 然后呢再把它并起来，然后再往下走。OK， that's something called CSP. OK, CSP. OK, class stage partial. That's so-called partial connection. OK, partial connection. If you take a look here, let me see. What did I say? Here, it divided into 2 parts along the channel dimension. OK, along the channel 就是在它的那个 channel 那边拆成2部分。OK. Now here's eventually this is the model. OK, here's the input. Now a half you call x0 prime and x0 double prime. X0 is the original input. It divided into 2 halves. OK, from the channel dimension. OK. Then you connect. OK. OK, 1 half you connect. Then you just copy it to the next convolution layer. The other half, double prime here, you do the convolution. Okay, convolution block. It doesn't mean just go for one single convolution. No, could be many. Then you do the concatenation. Okay, here you can see together here. It means then you concatenate together. Then you go for the same here. Okay. X1 prime and S1 double prime, then you do the convolution, then you concatenate, then you will have more, and then you go for the next and go on. Okay, that's what you do for the CSP. Okay, CSP, that's next. Okay, that's it. So the calculation has been reduced by half, right? Without sacrificing too many. Because what? Because something, you will do something here again. If you have, I may not have the time to talk about the Euro 7 probably next week. I will go quickly. Because for Euro 6, when you divide, you will divide not just into 2 groups, okay? The first half of the channel, the second half of channel, no, you divide a lot of group. And then when you do the concatenation, then you do the random shuffle. 像洗牌，它重新呢又把它重新组合，随机的组合，你知道意思吗？I mean for this if you have a layer like this, I mean the channel, you have the channel 1, channel 2, okay, and up to channel K. Then now the first you divide it into half, right? The first half and the second half. Now in Euro 7, no, it divides it into first group, second group, and third group, and so on. And then they do the thing like this, they do the convolution for each group. And later on, they do randomly shuffle for the concatenation. You know what I'm saying? 它会去洗牌，然后再把它凑在一起。But eventually, they will concatenate all together, and they found out it's better and faster because it is separated into more groups, so we can take the advantage of GPU, right? You can make a parallel computation. But in Euro 4, it's simply just divided into 2 groups. Okay, the original group and the second group. But anyway, when you do the concatenate, if just like Euro 7, if you do the shuffling, then it will be bad, right? Otherwise, you always take the very first half, okay, to do the convolution, and the second half will be just input to the next convolution layer. But when you do the shuffling, then you will, each feature map have the equal opportunity to do the convolution, but not all, okay? But not all, you do the convolution. Anyway, if you can reduce the channel, you know, the filter size, even if 3 by 3, now, right? If K is the number of channel, this is the original, but if we use, it divided it into G group, okay? Then you will be reduced the number of parameters significantly, and the computation time is also reduced. Okay, that's the idea how it works. Okay, but anyway, you do the concatenation. So when you go up to the concatenate, just like the DESNet, okay, you will take all the output from the previous layer as the input for this case for layer K, OK？ DESNet 是这样子嘛，会把前面所有的 convolution 的结果统统 concatenate 进来，OK？ And for the neck, the neck it is basically still based on the feature pyramid neck, but now changed to PAN. Okay, but we already talked about the feature pyramid network. Okay, so that we can handle different scales. Okay, we can skip this part, but for okay, we already mentioned this. Okay. And also, I should talk about the PN. Okay. Let me say this first. It also proposed to use a so-called spatial pyramid pooling layer. Now, take a look here. Okay. This is the original, the feature map. It divided into, for this case, 4 by 4. Which will have 16 grids. Okay? Then you take the maximum pooling. For each grid, you take the maximum pooling. Okay? Everyone follow me? So it converted into one dimensional. So for this one, you will have 16. Okay? But the depth is 250. So you have a 16 by 256. 256 is the challenge, okay? But if you divide this feature map into 16 by, 4 by 4, then you will have 16. And then the same feature map here, take a look, the same feature map, you can also divide it into 4 cells. And then you apply the maximum pooling again. So it will become, if we skip 256, then you will have a vector of 16. And then you have a vector of 4. Then you concatenate them all together. And finally, you use this, the input as one single. Okay, you just pick one maximum value and put it here. So it's so-called fixed length representation is good, which means will be invariant to the input size. You know what I'm saying? 也就是说哈，它这个 feature map 到这里的时候呢，它用不同，它实际上一样叫做 pyramid 金字塔，它把它拆成了4乘4，就有16个，它把16个呢变成了这个的向量的维度呢就是16，然后呢。或是呢，我只做2乘2，就是有4个，然后呢，再做一个1乘1，里面只挑最大值，把它留着，然后呢，我再把它 味道，最后一个就是 fully connected layer。你们看也是很聪明，所以 you can think of it as some fine features, fine details feature, okay, or local features. Then this will be more global features, and then they put them all together. So it's so-called fixed length vector representation is invariant to the input image size or the feature map because it's fixed, right? Even the original image is 1K by 1K, you can still divide it into 16 by 16, 4 by 4. I mean, the output is only 16. Even the size is 7K by 7K by 7K, just like your assignment number 5. It still have only 16, right? Okay, so that will be fixed. There's no need you need to change the size. So that's a good thing about it, okay? I'm sorry I didn't. Anyway, I'm thinking next week I think I had better to talk about the GN, okay, generated adversarial network. And if I can finish it and still have time, I can go back to talk about the key point of YOLO 4 and YOLO 7. Okay, there's no way, even you take a whole month, I think I cannot finish all the details about YOLO 4 and YOLO 7. Okay, so that's my plan. Okay, next week. But the basic idea about YOLO 4, you have already know something about it. Okay, should be no problem for. Okay, here's the pen. Okay, I will finish this next week. Okay. But again, this is a pen. Okay, bottom up, top down, and then bottom up again. Okay, and that's it. That's the basic idea for pen. Okay. An original pen, the connection is based on addition, but in YOLO 4, it changed to a notation. That's it. Okay, that's the basic idea. That's it. Okay. Okay. If I have time, finish it. Okay, next week. Otherwise, I will go for the GL. Okay, next week. Okay, it is another very important topic, and then we can finish what I need to talk about. And hopefully, next semester I can talk about transformer, especially for time series. For next semester class, I will focus on vector battery data and also time series. Basically, I won't say anything about image. Okay, so that's it. All I want to share with you. Okay, so focus on your assignment number 5, your term project. Okay, and try to get it done and prepare the slide that I need to print out. Okay, on the day, January 9th, right? Okay, 1月9号。